All across the world lie the footprints of our distant forefathers. There are skyscrapers thousands of years old, ancient manuscripts that reveal stories of awe-inspiring enormous weapons, and remnants of huge structures hidden at the bottom of the ocean. How could the ancient engineers possibly have achieved such phenomenal feats? Mega machines. As we rediscover the astonishing technology of our past, we are being forced to rethink all that we thought we knew about ancient civilizations. This is the story of the most powerful, complex, and awe-inspiring machines in the ancient world. Today, we have almost no conception that thousands of years ago, the Earth was populated with colossal machines. Cranes that transported tons of marble, aquatic claws designed to harpoon ships and drag them down to the ocean floor, and mechanical saws powered by the force of water. These remarkable devices were used to construct magnificent temples and monuments reaching to the heavens. Some of them would not be out of place on a modern building site.
Somebody traveling to a construction site of antiquity would have recognized the same machines which are used in a building site in modern times.
Yet mega machines were also found in the ultimate theater for new technology, the battlefield. Simple hand weapons were replaced with gigantic mechanized catapults and trebuchets, ancient weapons of mass destruction. Modern engineers are still seeking to decode the astonishing complexity of these designs and unravel how they would have worked.
There are a lot of large structures in the ancient time, such as temples, amphitheaters, and all these sort of buildings. They all, of course, needed building works in a very sophisticated way.
All over the world, from the desert kingdoms of Carthage to the Roman Empire, the great civilizations of antiquity built grand monuments on an astonishing scale. But what were the mega machines that created these incredible works really like? Can modern science uncover new insights into the techniques the ancient engineers would have used? One of the most widely built mega machines was a huge crane designed and built to hoist large weights. Ancient texts record that the first hoisting device was used around 500 BC in building the monuments of Ephesus in Pergamum, in what is now modern Turkey. But now, new evidence suggests that the first crane may have been invented much earlier than was previously believed. In Corinth, in what was once the heart of ancient Greece, archaeologists have made a series of startling discoveries. During a recent research expedition, researchers from the American School of Classical Studies in Athens uncovered 2 limestone coffins dating to almost 3,000 years ago.
We knew we had a tomb here because I could see part of the edge of the cut of the grave, but the students working with me were a little bit unsure. And after a couple of days digging down within the grave, we came across this simply enormous cover slab, and we knew we had a grave of considerable importance.
Archaeologists were totally baffled by these enormous sarcophagi for one simple reason: their weight.
The grave cutting is about 3 meters long and about 2 meters wide from east to west, and the sarcophagus is absolutely huge.
At over 3 tons each, neither of the coffins could have conceivably been lifted into the graves by hand. How could the ancient Greeks have thus performed such a precision maneuver on such a colossal object?
Probably the easiest way to do it would be to transport the stone on rollers and use oxen to haul it into place here. Then what they'd do is they'd roll the sarcophagus on the rollers over the top of the hole that they'd dug, and then they could turn ropes around the sarcophagus proper and make it steady by wrapping the ends of the ropes around something called Samson posts. You can then maintain the weight of the sarcophagus, pull out the rollers so that the sarcophagus is then just swinging free above the hole, and then using friction you can lower the block into place.
Archaeologists now have a new theory. The Greeks would have used an ancient crane to lower the coffins down into the graves. It is believed an A-frame structure was used in the design of the crane. The ropes were wrapped around the beam of the frame, allowing precision control when lowering the coffins.
So we have here monumental architecture for the dead below the ground, and we must be a step away or even a step behind having monumental architecture above the ground circa 900 BC.
We are still seeking to fully unravel the mystery of the Corinth coffins and the first crane. It provides a tantalizing glimpse of what ancient mega-machines could lie beneath the Earth's surface, awaiting discovery. Yet if the Corinth coffins were the first usage of an ancient crane, it was to take a true genius to understand the complex science behind how they are used. His name was Archimedes. Archimedes lived around 200 BC in Syracuse, which is now modern Sicily. He was to become known as the godfather of invention, a visionary who experimented with ideas far in advance of his time. Archimedes discovered a mathematical principle that now serves as the basis for countless modern machines, from cranes to motor cars: the lever. He deduced that you could lift incredibly heavy objects using little force if you had the correct lever and angle of leverage. Most famously, he claimed that if you gave him a big enough lever, he would be able to move the world.
It was really Archimedes' codification of the principles of the lever that allowed it to be used in a more sophisticated way as a component in larger machines.
Yet were his revolutionary ideas ever put into practice in his own time by his peers? This drawing depicts a harbor built at the port of Amathus in Cyprus to protect naval fleets against rough seas. The harbor was a monumental achievement. 5,000 huge stone blocks, each weighing over 3 tons, were laid down to provide shelter from the Mediterranean Sea.
This probably would have been a compound machine using levers, multiplication pulleys, and probably some sort of winding device, and again enabling massive weights to be lifted.
Ingeniously, as one section was finished, the crane would slide along to the next one. The Amathus Harbor crane transformed cranes into movable, dynamic mega-machines, able to adapt to the requirements of almost any terrain. Yet it was to be another Greek mega-machine that was critical to building perhaps the most influential structure in the ancient world. During the classical period between 450 and 330 BC, 3 important temples were erected on the ruins of the Acropolis: the Erechtheion, the Temple of Nike, and the Parthenon.
The Parthenon combines the unique ancient architecture and higher level of aesthetics that one could find. It has all these little secrets that make all the difference.
This building epitomizes the great achievements of the ancient Greeks. It has endured on top of the Acropolis in Athens for nearly 2,500 years. The craftsmanship seen in the building of Greek temples has never been surpassed. Every single massive block was hand-carved and set in place using a complex crane.
We know a lot about cranes thanks to direct information left by ancient builders in some representations, depictions, etc. on marble. It was powered by 10 men at most. The crane was 27 meters tall and it had the capacity to move parallel to the building and also to lean towards the building to lift the stone, then horizontally to move the stone, and then slowly to lower the stone to the level of positioning.
The secret of this mega-machine? Productivity. The mega cranes of the classical age were able to hold weights of up to 20 tons. These capstans increased the workers' efficiency by 20. Then the pulleys above increased it further by 3. So the combination of capstans and pulleys meant that the work of 10 men became that of 600 men. Almost overnight, productivity skyrocketed. It's no wonder then that the mega cranes of Athens were able to raise a block of stone every 15 minutes, and the entire Parthenon was finished in under 10 years, a tenth of the time it took to build the Great Pyramid at Giza. Some believe that even today we do not have the skills to match the quality of the work carried out by the ancient Greeks, as their cutting and placing was so incredibly detailed and precise.
Nobody knows exactly the secret of a worker. If somebody stopped this procedure, then you lose all the information. Today we are trying to understand how they did it. If you try to pass through the joint, it's impossible to put it inside. It means a perfect technique to match the two marble together. Today it's incredible.
There is evidence of ancient cranes littered across the world. There is even evidence of cranes used in fantastical circus-like theatrics. Ancient texts record how a lifting device known as the Oracle of the Dead was used for strange and occult rituals. Amazingly, people were given narcotic drinks and taken to a darkened cave. Here they would see the priest suspended from a crane like a modern-day magic man. To people of the time, he appeared as an apparition of the dead flying above them. Could the ancients really have created such an elaborate machine? For the foreseeable future, the truth about the Oracle of the Dead is likely to remain a mystery. We are still discovering the secrets of how and why cranes were used by the great civilizations of antiquity. But it is clear that it was the Romans who were to take these cranes to their zenith. Can we at last learn to uncover insights into the mega machines that built the largest empire in the ancient world? The ancient Greeks invented great cranes to build their beautiful temples and monuments. Yet it took an ancient superpower to develop this technology on a mass scale: the Romans. The mighty Roman Empire stretched over 3,000 miles from Britain in the west to Jordan in the east. Maintaining this vast patchwork of peoples under the Roman yoke needed quick conquests, followed by rapid building programs. Monuments were erected that left defeated territories intimidated for centuries. But the Romans did not have hundreds of years, like the Egyptians, to allow them to build these huge structures. They needed to find fast techniques, and to achieve this, they invented massive cranes to raise the buildings from the ground in record time. Rome called on the engineering genius of its finest architect, a man named Vitruvius. He devised several visionary designs for ancient cranes that were to prove instrumental in building the colossal structures of the Roman Empire. His most influential design used a wheel in order to multiply the awesome lifting power of the machine. The wheel was driven by a crew of 5 men walking inside. It would also use an intriguing technical approach when lifting a block of marble. A set of metal wedges would be inserted into an opening in the block of stone, which would slide into a specially constructed hole in the block. When all 3 wedges were in place and a locking pin attached, the block could be lifted. The large weight of the blocks helped lock them firmly in place as they were lifted. It was an ingenious method of lifting a stone block without the need of ropes under the stone. Some of Rome's most amazing structures were built using the same types of mega cranes, such as the awe-inspiring Trajan Column. Trajan's Column is a remarkable monument which towers high above Rome and which once would have been surrounded by a complex of elaborate Roman buildings.
Trajan's the emperor who takes as his ruling name biggest of all, Trajan Optimus Maximus. And if you're going to be the biggest emperor, you have the biggest column monument.
This vast structure is 98 feet high and has been created out of a series of 40-ton marble drums laid on top of each other with exceptional precision.
Inside that column is a helical stair. Those little slits are windows. So they had to cut each block with the internal staircase and have them perfectly aligned. The stones stay together, they don't shift. And what that takes is calibrating the joins absolutely.
Yet what kind of crane could possibly have been used to achieve such a feat? On the side of a Roman funeral relief, called the Relief of Hatari, is a find of supreme significance. It offers unique insight into how a crane would have been used in ancient Rome. It reveals that the Romans used quintuple pulley systems, powered by a crew of 5 specialized workers. It proves once and for all that the Romans had far more advanced crane technology than any other civilization in the ancient world. The Roman engineers constructing Trajan's Column used the most sophisticated cranes of their time. When Rome imported Egyptian obelisks, these powerful lifting devices were also used to erect the huge slabs of stone. Sadly, no fully intact cranes survive from the ancient world. It is only from works such as these magnificent obelisks that we can piece together the secrets of the cranes the ancient builders would have used. Yet in Germany, One remarkable new project is changing that. A team of modern engineers have reconstructed an ancient crane for the first time. Can we at last uncover how the ancient mega cranes would have looked in their heyday? This amazing crane was built 20 years ago as a reconstruction.
So this part of the crane is the capstan. That's the point where we start pulling. So 4 men are necessary to push these handles, and by doing so, winding up the cable on this vertical axle right here. From the capstan to the main crane, you get 1 cable, and this cable being wound up on the main wheel over there. This is the very basic principle of a transmission. So while winding up this cable from the capstan on the big wheel, at the same time you've got the small wheels on the axle winding up the cable from the stones that's to be lifted. That's very much the powerhouse of the crane. In this transmission you get a 4-fold power transmission, so you need 4 times the length of the cable, but you only need a 1/4 part of the power to pull it.
This extraordinary device is based on the same exact principles as every modern gearbox. Transmission increases the length of cable needed, but decreases the power needed to achieve activation.
Right here you see a very important feature of lifting up the stone block. This is a block with pulley wheels, and you see a number of pulley wheels down here and another set of pulley wheels up here. We have a sequence of machines lined up. So every time you reduce the power necessary and you increase the length of cable, and you line this up a number of times, and this in the end is very efficient.
So although the Xanten crane uses pulley technology to increase the power of man, the ancients also had another, even more unbelievable trick up their sleeves. They used wheels which could be automated to create power, giving birth to a new mega machine. At an ancient flour mill in the south of France at Barbegal, there is incredible evidence of this groundbreaking technology. The power to drive the millstones came from 16 water wheels. Yet as we seek to uncover the secrets of the ancient mega machines, we are faced with an even deeper mystery. How did the ancients cut the vast quantities of rock needed to build such colossal buildings in the first place? All across the world, from the statues of Rome to the temples of Greece or the pyramids of Egypt, man has forged great structures from stone. Now, modern engineers are seeking to piece together the mega machines that lie behind these super-sized constructions. And surprisingly, a remarkable find has recently surfaced that makes us wonder, did the ancients actually create a mechanical multi-blade saw? The ancients' megastructures were truly mind-boggling in scale. Thousands of years before modern trucks, cranes, or diggers, they built immense monuments cut from rock. In the past, it was believed that it was solely through the brute force of thousands of oxen and slaves that they created these amazing architectural feats. Now, modern engineers are discovering that our distant ancestors used mega machines. The stone used for the Greeks' Acropolis weighed more than 20 statues of liberty, yet it is the Romans' constructions whose sheer scale baffles most of us all. At the outermost reaches of the Roman Empire in Lebanon lies the Stone of the South. At over 1,200 tons in weight, this vast obelisk remains the largest piece of stonework ever crafted. How did the ancients cut the rock for their incredible building projects? And how did they transport this rock hundreds of miles to the construction sites? Our quest to unravel the mega machines behind cutting and moving the Stone of Jordan takes us on a voyage back 4,500 years to Egypt and the legendary pyramids of Giza. It took a century to place the 2.4 million limestone blocks in place. But what machines did the Egyptians use to create this wonderful ancient wonder?
You see this large mound of brick and debris. It's the remains of a construction ramp that was used to haul the stones that were course by course to build this tower of this gateway. The construction of the tower was never finished, and when the temple was cleared in the 19th and early 20th century, this particular mound was left in place as an example of how this construction technique was carried out.
Ramps were built on either side of the building, enabling construction by separate teams to be carried out on both sides simultaneously. In the Karnak Temple in Egypt, we can discover yet more clues as to the techniques of the ancient temple builders.
Once they piled the stones up for whatever part of the temple they were doing, like this column here, they then would have to cut it to the shape they wanted. So really what they're doing is they're piling up stones and then sculpting the temple. These blocks are going to be cut into a rounded shape, and then it's just a matter of working down from the top and trimming until they get the right dimensions and shape.
But how did they lift these 1,000-ton rocks and move them all over Egypt? In the quarry at Aswan, there is a monumental clue. This is the famous unfinished obelisk, still attached to the bedrock. Almost uniquely in the ancient world, we can see work in progress. This huge undertaking was suddenly abandoned when a crack appeared in the lower section. It is 130 feet long, and if finished, it would have weighed 1,000 tons.
To remove an obelisk like the unfinished obelisk in Aswan out of the bedding would have been problematic. Even nowadays with the machinery we have and the lifting device we have, it would still represent a very difficult task. Here lies a bit of a mystery of how they did it, but obviously they did it.
So how could the Egyptians have possibly done this without the use of cranes?
One suggestion is that they would drag an obelisk up a man-made embankment and then lower it down into a funnel-shaped pit and remove the sand from the bottom, thus allowing the obelisk to slip down into a vertical position before you clear away those ramps. An alternative suggestion is that the obelisk was raised up to 34 degrees and then erected by men pulling on ropes.
But recent evidence suggests that the Egyptians were even further advanced than we once realized. At a site in Karnak, archaeologists came upon a remarkable find, a vast block of stone that appears to have been cut not by hand, but by a sort of high-speed machine. Could the Egyptians, in fact, have developed mechanical saws?
Here in this basalt floor, you can clearly see here the mark left by the saw when they were cutting the block.
Evidence exists that suggests that these mechanisms were used to shear through massive sheets of rock in quarries. One machine has been suggested that consists of a frame which would have been anchored to the side of the quarry. A large, heavy block would have been placed in the machine. Underneath this was a stone-cutting saw. Amazingly, the machine was powered by multiple teams of oxen. Man and beast worked together to cut deep into the rock. Very same idea is used in this modern quarry in Egypt. Here, millions of tons of limestone have been cut from the bedrock using a mechanical saw, but replacing oxen with a powerful diesel engine. The ancient Egyptians used saws to carve the rock for some of the greatest monuments man has ever created. But there is evidence in Jerash in Jordan which may reveal that the ancients also developed a yet more advanced method of cutting. Close to the city of Amman, Jerash has within it an astonishing set of ruins. Archaeologists now believe that these tumbled-down remains were once an ancient workshop, used as a factory for cutting stone on an industrial scale. The construction method favored by the Byzantine builders was to use limestone with cosmetic facings of marble veneer, a cost-saving technique also used by the Romans to construct their beautiful buildings that stretched across their vast empire. This simple limestone slab is believed to hold the key to unlocking a fascinating secret. Could it show the signs of an ancient mechanical mega saw?
This is a drum. It's part of a column. In the Byzantine period, they brought this drum to this workshop to convert it to slabs. It is very perfect, which means it cannot be done by a hand. It is by a machine.
This is a reconstruction of the machine thought to have been used here. Hundreds of gallons of water power a water wheel connected to a central wooden shaft, which summons the vast energy needed to drive the great blades.
We know where the wheel was because of the location of the cranks.
The cranks would have been the powerhouse of this machine and were connected to two banks of quadruple sawing blades, which would cut precisely through the marble pillars.
It works by using abrasive materials like a sand.
The sand would create a friction, which would allow the iron blades to cut deep into the rock. The multi-bladed automatic cutting mill in Jerash is a fascinating new discovery. We now believe that thousands of years ago, there would have been similar saw cutters all over the globe. Automated mega machines were thus not just the preserve of the modern world, they were actually invented by the ancients. But once again, it was to be the Romans who were to push this ancient mega machine to its zenith. In 2,000-year-old texts written by the Roman engineer Pliny, there is a description of a remarkable cutting device unlike any other in the ancient world. Pliny describes what is believed to be the first mechanized water saw, yet it remains just that, a description. No one knows whether the design would work in practice. Richard Windley is a leading model maker and expert in recreating the inventions of our distant past.
This is a small model I've made which represents one way that this machine could have been put together. The motive power is supplied by the water wheel. The water wheel will rotate and the axle of the wheel is connected to the main drive wheel of the band. It uses the system of abrasion using probably emery sand. The emery will be made into a slurry with water.
It is believed that a worker would sit on the stone, dripping the emery slurry onto the rotating blade.
When the block has been sliced right the way through, the block shifted over and the next cut would then take place.
Does Pliny's ancient saw, powered by just sand, wire, and water, hold the key to discovering how the Romans carved their huge stone structures? As the ancients began to master machines that could cleave their way through rock, so they began to develop mega machines that could cut their way through people on the battlefield. They created massive machines of war, terrifying siege machines capable of destroying cities, and ancient superweapons that sunk whole naval fleets. Although it may seem strange to think of it now, the Greeks and Romans actually developed huge mega catapults to hurl massive weights to knock down battlements. Their siege engines were terrifying and held an arsenal of powerful weapons. Their enormous catapults used twisted ropes to create torsion, firing huge stone balls into castle walls.
The largest catapults, the mega catapults, would have stood 20, 30 feet high, so clearly psychologically daunting to any defender. These mega catapults were capable of breaking down battlements or knocking over entire ranks of soldiers. It must have been truly terrifying to face a machine like that.
In medieval times, there was a quantum leap in technology, which led to one of the most destructive war machines the world has ever known. Pulleys, ropes, and treadmills used in Greek and Roman cranes were adapted for use in a sophisticated weapon system. In Warwick Castle, England, a group of historians and reconstructors have built a full replica of one of these mega war machines.
What we've got is a 14th century siege catapult. It's called a trebuchet. It's invented in the 3rd century by the Chinese, and then the technology spread through to the Middle East, where we collected it in around the 11th century when the Europeans went on crusades there.
The main engine of this amazing machine would be a huge set of wheels to be walked in.
As they're rotating the wheels, it's rotating our central axle, which is taking in the winch rope, which you can see is connected to the top of the arm there. Now the guys just purely using their leg muscles are winching up that 5.5-ton counterweight.
The troops run the machine like hamsters in a wheel. Their own brute force powers its lethal destructive capabilities.
Right, as the arm's coming down now, I'm getting my trigger ready. All right, slow, and hold. And then we quite simply engage the large metal trigger into the ring.
The men will need to unwind the rope so the firing arm can be released. All the pressure of this huge primed machine is focused on the firing pin.
As you see now, the wheels going the opposite way around. We're undoing the rope there to get plenty of slack.
The energy stored up in this simple wooden siege buster was awe-inspiring.
We measure energy in what we call joules. A professional baseball pitcher throws the ball with 2 joules of energy. Now, we're not throwing a baseball, we're throwing a 33-pound boulder, and we're throwing that with roughly 100 to 120,000 joules of energy.
That's the equivalent to driving a 1-ton pickup truck into a house at around 60 miles per hour. For our particular experiment, we wanted to test for the first time the speed of this massive weapon.
One of our crew has got a police speed camera, the sort of things that you use in radar traps, and when we take the shot, what we're going to do is we're going to try and see how fast the ball accelerates down the tray and see if we can try and record its top speed just before it leaves the machine.
132 miles an hour.
It looks like the ball accelerated up to 132 miles an hour. Now that's some sort of energy. That acceleration was over a 5-metre distance in under a second. Now that's faster than any Formula 1 car and a faster acceleration than a modern jet fighter from takeoff. Whether it's a medieval trebuchet, a Greek ballista, or a Roman mangonel, the torsion catapults of their time, it's not really a question of are we going to knock down this castle, it's just a question of when we're going to knock down this castle.
Have a care!
But as incredible as these machines were, there were still other ingenious mega war machines which were invented by the ancients. On the island of Syracuse around 200 BC, Archimedes developed a number of catapults to repel the most invincible fighting force the ancient world had ever known, the Romans. But he also invented other ingenious devices, many of which would astound military engineers today. As an island, Syracuse had a single critical weak point, making it vulnerable to enemy invasion: its harbor. In response, Archimedes devised an astonishing yet ingenious defense.
Archimedes developed a machine known as the claw, which was designed to grab the prow of the Roman ships, lift them into the air and suddenly drop them again, hopefully capsizing the vessel.
The claw was to become enshrined in legend as an ancient superweapon that sunk entire fleets and struck fear into the hearts of the Roman sea captains. But it is now thought that Archimedes may have developed an even more cunning machine, a device that lay hidden beneath the surface of the water, ready to pounce on unsuspecting ships. It would be known as the Archimedes Ship Shaker.
One can imagine trying to disable a ship. A very good way is to knock it over. If you get it off balance slightly and people start to slide, maybe you can tip the thing or at least really upset the oarsmen. If they get their oars tangled, they've had it.
Although archaeological records are scarce, stories of its existence have been linked with Archimedes. The idea was that a ship would sail into an apparently undefended harbor, but unknown to the soldiers on board, they were sailing right into a giant Venus flytrap underwater. As the ship docked, a massive spike would drive upwards into the ship, paralyzing the ship and its crew. Then a huge claw would come out of the water and engulf the ship entirely. With the ship neutralized and powerless, the mechanism would shake the ship from side to side before pulling the ship and its crew to the bottom of the ocean. The Archimedes Ship Shaker may have been powered by a team of oxen who would pull ropes to operate the actions of the machine. The oxen were hidden by a giant screen, so the harbor seemed as if it was deserted. The Ship Shaker was a cunning device created to trick the unsuspecting Romans into believing they could dock safely, yet the dangerous mechanism was waiting under the surface to destroy their ships. It is an intriguing device, but it seems like the stuff of Hollywood battles. Although the story is based in legend, what is remarkable is that every element of this machine employs technology that was actually in use at the time. There were many mega machines in the ancient world, but perhaps none so intriguing as those which were found in Alexandria. It is here where the ancient Greeks' greatest inventors worked and studied, and the machines they are thought to have created were sophisticated far beyond what we imagine ancient machines could be. One of their greatest achievements was the Pharos Lighthouse, a multi-purpose mega-machine used to guide ships into the harbor as well as to destroy them. There was one building from the ancient world which was the largest and most complex machine in antiquity. Its reputation would have stretched far and wide, and today it is recognized as one of the 7 wonders of the ancient world. It was known as the Pharos Lighthouse of Alexandria.
Despite the numerous races which passed through, the Greeks, Romans, Byzantiums, the Arabs, from the time it was built, they all respected the lighthouse, and no one tried to destroy it.
The Pharos Lighthouse was begun in the reign of Ptolemy I and completed in the reign of Ptolemy II. It was constructed on quite an enormous scale.
Estimated to have been between 500 and 600 feet high, it truly was an ancient skyscraper. It is thought to have been the tallest tower ever constructed until the Eiffel Tower was built in 1889.
It was the biggest structure at the time, and it was not a coincidence that it was built in Egypt, where there was a long tradition in constructing enormous buildings such as the pyramids.
The Pharos Lighthouse was constructed around 290 BC. Its primary function was to provide a beacon for the harbor at Alexandria. Today, standing on its former site is a military fort. Although nothing exists of the lighthouse, the harbor has recently become the center of interest, as archaeologists have discovered ancient marvels that may cause us to rewrite the history books.
Most of the stones that make up the lighthouse were brought from the south of Egypt. We have found underwater a huge amount of granite. The majority of the lighthouse is built of pink granite from Aswan.
In the shadows of the Pharos Lighthouse are a set of intriguing pink granite blocks. These slabs of stone are believed by archaeologists to be sections of the Pharos Lighthouse, but more intriguing objects are to be found in the harbor at Alexandria.
We are just over the site where the blocks are submerged, among which there are a number of pieces that come from the Pharos Lighthouse, and some from the monuments that were part of the decor of the lighthouse, and in particular, the entrance.
There is also another ancient relic which could throw light on the Pharos construction. It is a structure known as the Alabaster Doorway. It is believed that the entrance to the Pharos Lighthouse would have looked very similar to this structure. The size of the Pharos Lighthouse would dominate the Alexandria skyline for over 1,000 years, and it stayed intact for so long because of how it was constructed.
The Pharos Lighthouse was built in 3 stories. The lower story was on a square section, the second was octagonal, and the third was circular, and then the light projecting devices were on the top. We're confronted with the Ptolemies producing something which is bigger and better than anybody else has. This building is propaganda in stone.
Some people now believe there may have been unusual mechanical automata on the outside of the lighthouse.
Around the second level were 8 bronze statues, which would follow the route of the sun. We do not know how this was possible, or in fact if it is true.
There was another machine which told the hours of the day by the use of melodic sounds, and amazingly, some writers claim that the lighthouse was even used as a massive telescope.
I don't think that I would want to go along with the view that it's the first telescope in history. What you could do, of course, was climb up inside the thing and look out of the top, and that gave you a panoramic view of the delta area and indeed of the sea.
It is a romantic notion that the lighthouse could have been used as a telescope, so the Egyptian leader could observe whether the leaders of Constantinople, the other great city in antiquity, was preparing a fleet of ships to attack it. But the curvature of the earth would not have allowed this to occur. So could the lighthouse have been an early warning device? Richard Windley has constructed a model of one of the devices thought to have been a part of the Pharos Lighthouse.
Philon of Byzantium was one of the great brains of his generation, and one of the things he's often credited with is the design and making of some kind of warning device which was mounted on the Pharos lighthouse. There is just one tantalizing reference to a steam siren which utilizes a spinning wheel.
2,000 years ago, the lighthouse would have contained a great beacon. This towering furnace would have produced vast quantities of heat, able to fire steam-powered devices.
In this case, we've got a small boiler. The steam from this boiler would come up the tube here, through an on-off stopcock there, which would give control. Inside this little section here is a revolving wheel, which has got small holes in it. And it's forced to rotate a bit like a turbine, so that the pressure of steam actually spins the wheel, and this produces an audible tone.
When air is forced through the alarm by steam or this modern pump, Richard's model reveals an extraordinary truth. The Lighthouse of Alexandria could once have been a warning siren. Not only would sound be used, but the ancients could also harness the power of light. The lighthouse would need to be a beacon for ships to guide them safely into Alexandria's harbor. It would therefore need some way of using a fire or reflected light to produce a beacon.
The light of the lighthouse reached about 30 miles. This is a mystery because we have many issues relating to the fire which was lit on the lighthouse. For example, we know that in Egypt there was no wood. There were no big forests from where trees could be cut to take wood to feed the fire.
Without an abundance of wood in Egypt, the light projected at night had to be produced with as little amount of burning material as possible. This has led experts to believe that a small fire would be used at night, but it would need to be amplified. Hence, the first theory was that the fire was at the bottom of the Pharos and reflected with a series of complex mirrors inside the building to finally reach the top and be reflected out to sea, almost like an ancient laser beam. But did they have this optical technology available?
And Alexandria and Pergamon are actually very important with this. They know how to refract and focus light. They play light games. They know their optics.
The second theory was that the fire was up high on the Pharos and would then again be reflected out to sea. There are also references in ancient texts of a strange crystal reflecting light over vast distances. But in daylight, it is believed a mirror would be used to reflect the sun. Richard Windley has been experimenting with mirror technology.
Given the height of the Pharos, this would give the horizon distance of only about 30 miles, which is well within the range of a significant mirror. My theory, and it is only a theory, is that a mirror would collect the sun's rays from somewhere in this direction into this top mirror, which had to be precisely angled so that the beam went absolutely vertically down below, which then could be scanned, i.e. rotated, to distribute the light around a wide area.
The ancients would have had to calculate the angles of reflection to incredible accuracy. One tiny miscalculation and the beam would fail to fire.
There's a small cam follower here, which is a lever, and that is connected by these little levers and cams here to achieve the desired angle of the mirror.
But will Richard's model work when put to the test?
I'm turning the handle now, and here we go. There is the sunbeam being distributed. And we have our lighthouse.
But there is another strange theory that the lighthouse was in effect a multi-purposed machine, a mega weapon from antiquity.
Somebody gets the idea you could actually use this for a military weapon.
This is not a new concept in the ancient world, because it is claimed that the same type of weaponry was used by Archimedes with his burning mirrors.
I remind here that the reflectors of the Alexandria lighthouse have close similarities with the reflectors of Archimedes, with which he burnt the fleet of the Romans during the Syracuse period.
While the true effectiveness of ancient mirror technology is unknown, what is truly awe-inspiring is that the Pharos lighthouse was a magnificent structure and remained so until the 13th century AD, a span of some 1,600 years when it was finally destroyed by an earthquake. It was the ultimate mega machine. Although we may like to believe that mega machines were a 20th century invention, we would be wrong in thinking so. New insights from modern engineering have revealed that without complex ancient machines, many of the celebrated monuments of antiquity would never have been created. In years to come, we will uncover more elaborate machines, and we'll have to take a second look at how advanced we thought the ancients really were. As ancient inventors finally get their due, we will have to admit that mega machines did have their birth in the ancient world.